Lesson 3.1 covering relations. A relation is a set of ordered pairs or coordinates. In this lesson, you'll also be introduced to a couple other vocabulary terms. Independent variable. An independent variable is basically what you can control, something that you have control of or you start with. This is always placed on the x-axis. It is the first term in an ordered pair of coordinates, so it's your x value. Dependent variable in the relation would be something that depends upon your independent variable. This is what you do not have control of. This would be the second term in the ordered pair, so your y value. So therefore, when you graph, this would be placed on your y-axis. Other lingo that they'll introduce here is domain and range. Domain is your independent variable. They're universal. You can use domain, you can use independent variable. Basically, they are your x values in the relation. It is the first number in the ordered pairs. Leaving you with range. Range would be your dependent variables, the y value on the graph. This would be the second number in a coordinate or ordered pair. In your first example, in example 1, you need to identify the independent and dependent variables for each relation. A, Jerry works at a hardware store. The more hours he works, the more money he is paid. In this situation, the independent, the one that we can control, would be the number of hours worked. So this would be your x value independent variable, number of hours worked. Your dependent variable on your y-axis hinges on your independent variable. In this case, it would be the money he makes for the hours he works. So it would be y dependent, the money paid for working. Example 2, Cal is wrapping gifts. He uses different amounts of paper to wrap boxes for different sizes. Again, what we can control here, the independent variable, your x value, is the box size. This is what we would have control over. The bigger the box, the smaller the box, well, that's going to hinge on your dependent variable, which is the amount of wrapping paper we'd use for the size of that box. So x independent, box size, y dependent, the amount of wrapping paper used. Obviously, the bigger the box, the more wrapping paper. In example 2, they give us a relation. The relation, remember, a relation is just a set of ordered pairs. In this case, we have 4 ordered pairs. We're to express a relation as a table and a graph. Here's your table, your basic XY table. We need to pull our values from our ordered pairs. So if you're looking at the first one here, 0, 4, 0 is your x value, 4 is your y value. So go ahead and fill in the rest of your table. It should look something similar to this after you pull out all your x and y values. Next, you're able to, they want you to graph it. So basically, go ahead and plot each coordinate on the graph. When you plot each coordinate, it will look something similar to that. 0, 4 would be here, negative 3, 4, and so on. In part B, they would like you to determine the domain and the range. Remember, our domain is our independent variable. It is the x value. So here is the x values. Our domain would be 0, negative 3, 5, and 1. Your range would be your y values. So we have 4, 2, and negative 1. Notice 4 is listed twice here. We only need to list it once. 4, 2, and negative 1. In our last example, we're to use each graph to determine the domain and range. In part A, x equals 3 is graphed. X equals 3 is a linear line, straight line. It's a vertical. completely vertical. Now, my graph only goes to 6 and -6 here. But remember, this line would go on forever. Your domain, your x values, in this case would be 3. If you think about it, you have 3, 0, 3, 1, 3, 2, 3, 3, 3, 4. Below you would have 3, -1, 3, -2. So your x value is always 3. Your y value on this case, with the graph going on forever in both directions, we would state that our range y value would be all real numbers. It covers all real numbers. Part 2, B, you have this equation. Again, it's graphed. This here would continue on forever. So your x values, your domain, here's your x-axis. And this graph is called a parabola, which we'll be getting into here shortly. This, as we get towards the top, it keeps getting wider and wider. If this continued on forever, it would continue on, and our x values would keep getting larger and larger. So our x values, our domain, would be all real numbers. Your y value, your range, well, if you look at this in this parabola here, you have a minimum. This minimum for y is -1. And then it covers all these y values above. So what we'd want to do is write this as an inequality, stating that your range or your y values, has to be greater than or equal to -1. Here's -1, it's equal to it, and here's the values where y is greater than -1. This concludes our lesson on 3-1 relations.